Hello everyone, welcome back to my channel Ali Sir Chemistry Class for All. From last 3 or 4 weeks, I did not have done any videos which is uploaded in YouTube my channel Ali Sir Chemistry Class for All. Today I have decided to make a video for those students who are going to sit in class 12 examinations or class 11 examinations or honors examination. This time is the exam sessions. This December, January, February, this time is exam session. So I have decided to make some video regarding this. You have already seen here written the conversions between one hydrocarbon to another hydrocarbons by simple and easy methods. Today's topic is basically on conversions, which is one of the most important topics in organic chemistry. If you know the conversion properly, every reaction must have to known. Every reaction, every reagent must have to known to carry out any conversion, and it is the most interesting and simple way to know the conversion in organic chemistry. So let us try to do this conversions in a simplest manner. Just you see how easy is that. Just you see how easy is that. I have decided to make this conversion class in different part. First part, you have already seen that written conversion between one hydrocarbon to another hydrocarbon. So we basically focus in this class the interconversion between alkane to alkene to alkyne, or reverse alkyne to alkene to alkane. So all of we know hydrocarbon means the compounds which containing only carbon and hydrogen atoms. Only carbon and hydrogen atoms. For examples, all of you know one is saturated and another is unsaturated. Saturated hydrocarbon means all carbon is in sp3 hybridized. So that types of molecules are called alkanes. All of you know, just I am doing some basic idea. Unsaturated hydrocarbon means alkenes and alkynes. Alkenes containing minimum one double bond and alkyne containing minimum one triple bonds. So today's class is basically on the conversion between three types of compounds, which is already written in the board, which is alkanes, alkenes and alkynes. So it is very easy and you don't have to mug up. Just you have to remember some reagent and some reactions, and you can do it by using the reagent and by simple method which I am going to discuss now. So let us take some simple examples. Always try to study by simple examples and then simple to difficult. So first of all, I am given examples. Say, convert methane to ethane. That means the transformation is alkane to alkane, lower alkane to higher alkane. So here transformation you see methane to ethane. First of all, you have to know the structure of the given compound. In examination, sometimes structure are given, but sometimes IPC nomenclature or commercial name is given. So these types of name you have to know. You know the methane, the structure of methane is CH4 and ethane is CH3, CH3, or you can say C2H6. So both these types of molecules are alkane. So the transformations begins from alkane to alkane. Clearly seen that here only one carbon atom is present and here two carbon atom is present. So number of carbon is doubled. So initially, you remember the most important reactions have you all learned. I know that have you all learned. Barge reaction. Barge reaction for the preparation of symmetrical alkane. If you see this alkane, ethane is a symmetrical alkane. CH3, that means if you divide it here, we get two alkyl group, one CH3 left side, another CH3 right side. So this type of molecule is called symmetrical molecule. Whenever you see any symmetrical alkane is present, initially and instantly you thought that you have to thought that we used Barge reaction anyhow. So Barge reaction, all of you know, Barge reaction is a reaction where we can prepare a symmetrical alkane by using the corresponding alkyl halide. So to prepare this alkane, ethane, we have to use CH3Cl as a source of alkyl halide. So now you can easily convert from methane to ethane. So first you have to prepare methyl chloride from methane. All of you know chlorine, sunlight. If you used chlorine in presence of sunlight, what you will get? We will get CH3Cl, methyl chloride. Methyl chloride. Now it becomes easy. We have already obtained methyl chloride. Now we use Barge reaction, 2Na dry ether. You will easily get CH3. So you can see that how easily we can convert methane to ethane. This is only two-step process. First we have used chlorine in presence of sunlight, which is known as halogenation of alkanes. Halogenation of alkanes. And this one, second one is Barge reaction, which is one of the most important reaction for the preparation of symmetrical alkane. So you can see how easy is that methane transformation of ethane from methane. I have again written here CH4 to C2H6. So first step was chlorine in presence of H nu or sunlight. Sunlight is a source of energy, which is a free radical reactions. Initially, we get CH3Cl and then 2Na dry ether. We get CH3. So it is a two-step process, conversion of ethane from methane. Now I am moving to another examples or another conversions. I am going to increase the number of carbon. Say methane to propane. Methane to propane. So whenever we are doing any conversion, we have to first look at the molecular structure. And what is the difference between the starting material and the product, final product? Here it is written methane and propane. All of you know propane CH3, CH2, CH3. So in propane, if you see what type of alkane is this, I have already told you alkane are two types. One is symmetrical alkane and another is unsymmetrical alkane. Symmetrical means two alkyl groups are same. If we divided the alkane, we get the two equal groups, two equal alkyl groups, and if you divide, then that types of alkane is called symmetrical alkane. And unsymmetrical alkane is an alkane. If we divided the alkane into two groups, both the groups are different. So you see that here, if we cut from this point, this bond, we get methyl group and CH2, CH3 group. These both group are different. So this alkane is an unsymmetrical alkane. This alkane is an unsymmetrical alkane. So we can use the Barge reaction for the preparation of unsymmetrical alkane. Barge reaction is only applicable for the preparation of symmetrical alkane. So you have to think about it. So first method, that is we have done in example 1, the Barge reaction. This type of reaction cannot be used here because the alkane is an unsymmetrical alkane. So we must remember another process for the preparation of unsymmetrical alkane, which is called Core-House synthesis. Core-House. First step is the same. Chlorine in presence of HNu or sunlight will get CH3Cl. Then use 2Li dry ether. It is also an organometallic reagent. CH3Li, we will get CH3Li, methyl lithium. And then you use CuI, which is called cuprous iodide, CuI. Here the valency of copper is +1 and iodine is -1. So +1 means As and +2 means Ik. So this is cuprous iodide. If you use cuprous iodide, we get CH3 2Culi. This type of reagent is called Core-House reagent. Now, what is the beauty of this reagent? The beauty of this reagent is here the methyl group is acting as a nucleophile, or it can act as a base. Basically, we are going to use this Core-House reagent here as a nucleophile. So, our final product is propane, 3 carbon atom is present. But in R2CuLi or CH3 2Culi, only one methyl group is present. So, to carry out the conversion, we have to use another alkyl halide with Core-House reagent, which is called CH3CH2Cl. CH3CH2Cl or Br will get easily CH3CH2CH3. So I have learned here two methods for the preparation of for the preparation of ethane from methane and for the preparation of propane from methane. That means preparation of symmetrical alkane and preparation of unsymmetrical alkane. In first examples, we used the most important reaction which is used for the preparation of symmetrical alkane called Barge reaction. But in second examples, the alkanes, the final alkanes is unsymmetrical alkane. So we can't use Barge reaction. In spite of Barge reaction, we can use here the Core-House reagent, which is already written here. So We have to remember both the reactions for different purpose. Now I am written clearly here again. CH4, Cl2, H nu, CH3, Cl, 2 Li, dry ether, CH3 whole twice, Cu Li. And then we have to use CH3, CH2, Cl or Br or I, anything you can use. Finally, we will get CH3, CH2, CH3. This is another method for the preparation of propane from methane. We have also secondary examples, or another process for this conversion for the preparation of unsymmetrical alkane from an alkyl halide. So how can you use this? You see there, this type of compound is called organometallic reagent. What is this called? This is called organometallic reagent. Why this is called organometallic reagent? But in Bengali, which is called জৈব ধাতব যৌগ. জৈব ধাতব যৌগ. That means when in a compound, a metal is directly bonded to the carbon atom. When in a compound, the metal is directly bonded to the carbon atom, that compounds are called organometallic compound. Okay, you see the compound is CH3 whole twice Cu CH3 Li. So the carbon is directly attached with copper. So this compound is called organometallic compound. So by using this concept, we can say that in process B, in spite of Coriolis reagent, we can also use a Grignard reagent, which is one of the most important reagent in organic chemistry, and it has the maximum applications for the preparations of different types of alcohol, primary alcohol, secondary alcohol, tertiary alcohol, acids, ketone, aldehydes, different types of compounds you can prepare from Grignard reagent. So in spite of R2CuLi or Coriolis reagent, we can also use Grignard reagent. Let's see here. In process B, we are using the same method, chlorine H nu. What we will get? CH3Cl. Now we convert this CH3Cl into Grignard reagent. You know, all of you know, Grignard reagent is prepared. How Grignard reagent is prepared? Grignard reagent is prepared by the treatment of alkyl halide in presence of dry ether with magnesium. So when methyl chloride is treated with magnesium in dry ether, we will get CH3MgCl. So here CH3 is delta negative, this is delta positive. Now if you react this Grignard reagent, this is called Grignard reagent. Now if you react with this Grignard reagent with ethyl chloride, it will attract here, which is simply SN2 type reaction. We will get our desired compound, which is propane. So there are lots of methods, lots of way in conversion. In conversion, you can use any types of reactions for your choice. So I have written here two types of way, A and B. Whatever you like, you can write in exam. So in methane to propane, already 2 carbon is increased. We can use 2 or 3 or any, whatever we want. We can increase the number of carbon from one alkane to another alkanes by increasing the number of carbon atoms from lower alkane to higher alkanes. So in first 2 examples, I have given the 2 conversion, that is methane to ethane and methane to propane. So what is the basic of this conversion? We have converted lower alkane into higher alkane. That lower alkane means number of carbon atom is less, and higher alkane means number of carbon atom is more. So we have used simple reactions, basically two or three simple reactions. One is halogenation of alkanes, another is Barth reaction, which is used for the preparation of or for the conversion of symmetrical alkane, and another reaction is Corehouse synthesis, which is used for the preparation of unsymmetrical alkane, and another reaction is Grignard reagent, which is also used for the preparation of symmetrical as well as unsymmetrical reagent. We can use Grignard reagent in any types of any types of reactions for the preparation of symmetrical as well as for the preparation of unsymmetrical alkane. I think this is clear for all of you. Now we are moving to some other examples. That is from reverse. So first one, whatever we have done is methane to propane, methane to ethane, methane to butane. These two we have already done. This is your homework. Methane to butane. You can change ethane to butane. Number 5, butane to pentane. Whatever you imagine, you can convert. Okay, no problem. Just simple 3 or 4 reaction you have to remember for this type. One is Barth reaction, another one is halogenations, and another one is Grignard reagent, and last one is Corehouse reagent. So first two we have already done. In practice, in home, you will do the 3, 4, and 5, and you can send me by doing this in my Facebook page, which link I will send you, or in my YouTube channel page, or anywhere, whatever I will give also personal number, you can send it. So this is your homework: methane to butane, ethane to butane, butane to pentane. Okay. So here we have done lower alkane to higher alkane conversion. So whatever we have learned here, I am concluding. We have converted lower chain alkane to higher chain alkane. What types of reaction we have used here? First one is halogenation. Number two is Barth reaction. Which is applicable only for symmetrical alkane. Number 3 is Corehouse synthesis. Number 4 is Grignard reagent. So these 4 reactions you have to remember for the conversion of lower chain alkane to higher chain alkanes. Okay. Now we are moving to the just reverse one, that is higher alkane to lower alkane. So now our target is the conversion of higher alkane to lower alkane. Higher alkane to lower alkane, so you can easily see that CH3 to say CH4. CH3 CH2 CH4, that is ethane. Ethane to methane. These are conversions. Conversions and chemical reactions are different. In conversion, you can use any types of reaction which is applicable for anywhere, but in actually conversion there is a lots of difference between actual reaction and conversion. So in conversion there are so many ways. You used the most simplest way, as if you have the 2 or 3 different path or 2 different way, you always try to use simplest pathway. Okay, so now we move to ethane to methane. How can you convert ethane to methane? So you can see that there is a decrease of number of carbon from 2 to 1. So anyhow you have to break this bond. The concept is you have to break this bond. So this is a CC sigma bond. If you see, this is a CC sigma bond. That is, dipole moment of this bond is 0. There is no electronegativity difference. You can clearly see that there is no electronegativity difference between carbon and carbon. So to break this bond is very difficult. So we have to think about it. We have to think about how we can convert this ethane to methane. So indirectly we cannot convert it. We have to think about it. If we convert ethane to another types of compound, that is, we know the most important reactions of alkane is halogenation. So you have to use that reaction. If you use chlorine in presence of H nu, we will get ethyl chloride. Okay. Now see, ethyl chloride undergoes elimination reaction to form an alkene. Ethyl chloride, this is alpha carbon, this is beta carbon. If you use sodium ethoxide in presence of ethanol, we will get ethylene. Okay. This reaction is called E2 elimination. If anybody don't know it, you see in your book, you can see any book and reference book where you have to see, you have learned about E2 elimination reaction. What is E2 elimination? When an alkyl halide which is containing at least one beta hydrogen. What is E2 reaction? I am again repeating. When an alkyl halide which is containing minimum one beta hydrogen is treated with sodium ethoxide ethanol or a base, we get an alkene. You see that this is halogen, this carbon is alpha, this carbon is beta. So in beta carbon there is already 3 hydrogen present. So if you treat this ethyl chloride with sodium ethoxide and ethanol, we will get alkene. So we move from ethane to ethylene. Now our job doesn't over. We have to move from this ethane to methane. This ethylene to methane molecule. Now you see, this is a double bond. All of you know, I think all of you know the reactions which is known as ozonolysis. By using this ozonolysis reaction, we can easily break this bond. All of you know, by using this ozonolysis reaction, what is the reaction? By ozone in inert solvent CCl4, zinc, water, what we'll get? We'll get, just cut it, this bond, add it oxygen to oxygen plus CH2 double bond O. So what we'll get? We'll get a formaldehyde molecule, CH2 double bonded O. I'm just removing this Let's write CH2 double bond O. Now we move from CH2 double bond O to CH4. What is this compound? This is known as carbonyl compound. Carbonyl compound, and this compound is known as alkane or hydrocarbon. There are three different methods for this conversion. That means which conversions? Carbonyl to alkane, which is simply reduction reaction, which is simply reduction. That C double bonded O is converted into CH2. So oxygen is liberated and hydrogen is added. So this is one type of reduction reaction. All of you know the most important reactions about for this conversion is, all of you know, I believe that all of you know, which is known as Clemenson reduction. What types of reaction is it called? This is called Clemenson reduction. Another reaction is WK reduction, Wolff-Kishner reduction. So these two reactions are different from each other. What is the difference? One reaction, that is Clemenson reduction, is proceed in acidic medium. We use zinc HCl, that is acidic medium. But in Wolff-Kishner reduction or WK reduction, or in WK reduction, we used basic medium. So just use any type of reaction, whatever I have said, you can use Clemenson as well as WK reduction. I am using a Clemenson reduction. Zinc Hg takes zinc amalgam HCl. So the carbonyl compound is converted into methane. So this is interesting, very interesting problem. So we have converted higher alkane to lower alkane. So whenever you have to convert a higher alkane to lower alkane, you have to go through via the intermediate formation of an alkene. Otherwise, you cannot break the bond. You cannot break the chain. You cannot reduce the number of carbon atom. So you have to go through this intermediate, which is called an alkene. Just I am writing again, so you can easily understand this. Time doesn't matter if you understand. I am always said to the student that whatever you have learned, learn properly. Don't be hurry up. Don't be bother about the syllabus. Don't be hurry up. Just whatever you have learned, you learn it properly, and it will be best for you. If you learn 3 questions every day and learn 30 questions every day, what is the difference between there? If you learn 3 and you write it 3 properly, that is the best. But if you learn 30 questions but you can't write any one of them one of the questions from out of this 30 questions properly, that is meaningless. So don't focus on your quantity. You increase your increase your quality, the quality of answer, the quality of reading, the quality of presentations. You increase your quality, not quantity. Okay, so I am writing again CH3 Cl2 H nu, or sunlight. What we will get? Ethyl chloride. You use sodium ethoxide. Ethanol. What we will get? Alkene. And then do ozonolysis, O3, CCl4, and then zinc, water. What you will get? 2 moles of formaldehyde, and then use Clemenson reduction. What we will get? Methane. So we transfer ethane to methane. So only new type of reaction whatever we have learned, this E2 and this ozonolysis and prevention. This one is already we have done in previous examples. Now we are moving to another problem. Ethane to ethane, not ethane. Propane to ethane. What is propane? Propane means 3 carbon atoms, CH3, CH2, CH3, and ethane, CH3, CH3. So one carbon had been reduced here. So if we reduced one carbon, so the conversion will be done. Now we are using the same method, chlorine HU. This carbon is most reactive. This hydrogen is most reactive because this is 2 degree and this is 1 degree. All of you know about the halogenation. If you don't know, just go through any books and read the halogenation of alkanes. So what we will get? CH3, CH, Cl, CH3. Use elimination reaction, same method. Sodium ethoxide, ethanol. What will we get? Propene. And again use ozonolysis, CCl4, zinc water. What will we get? We will get 2 products, but one of them is acetaldehyde. So again you use Clemenson reduction, zinc, HGX, HCl, will get the desired compound, which is ethane. Okay, so the process is too much easy. It is too simple, very much simple. Whatever you called, it is very much simple. बहुत easy है, कोई दिक्कत नहीं इसमें. बहुत easy है ये. लोअर एल्केन से हायर एल्केन एंड हायर एल्केन से लोअर एल्केन. कैसे हम लोग कन्वर्ट करते हैं सिखा इधर. 2 और 3 एग्जांपल, 2 करके 4 एग्जांपल दिया और कुछ प्रॉब्लम में दिया. होमवर्क तो घर में प्रैक्टिस कीजिए. So what type of reaction we have to remember about this conversion? I am writing again. That means lower alkane to higher alkane and vice versa. First one is halogenation of alkanes. Number 2 is elimination of alkyl halides. Number 3 is Bart's reaction for symmetrical alkane. This reaction, Bart's reaction, is used only for symmetrical alkane and increasing the number of carbon atoms. Number 4, Grignard reagent. Number 5, Corehouse reagent or Coriolis reaction. Number 6, ozonolysis. Number 7 is Clemenson reduction. Clemenson reduction. So 1, 2, 3, 4, 5, 6, 7. These 7 reactions you must have to know about this conversion. To do the conversion properly, you must have to know these 7 types of reactions. One is halogenations, another is eliminations, Barge reaction, Grignard reaction, Coriolis reaction, ozonolysis, Clemenson reduction. So if anybody, any students or any teacher is aware about the conversion, he must have to remember all the reactions. Okay. Now we shifted our attention to one hydrocarbon to another hydrocarbon, that is saturated to unsaturated. That means now we are going to taught. Now I am going to taught. We are going to learn about the conversion of alkane to alkene and alkynes and vice versa. Okay, one by one I am doing here. First, alkane to alkene. This type of examples I have already done in previous examples. That is the conversion of higher alkane to lower alkane. Okay. Again I am doing here alkane to alkenes. Say for examples, ethane to ethylene. Very easy. Ethane, the structure is CH2, CH3, CH3. You use chlorination of chlorination reaction, CH3, CH2, Cl, and then use elimination, NaOH, ethanol. You will get CH2 double bond CH2. This is known as E2 elimination or beta elimination. E2 elimination. Okay. So very easy. Ethane to ethylene. Sorry, I have written here ethane to ethene. ETHANE. Ethane to ethene. Now it is okay. This is called ethane, and this is ethene. So very easy. This is only 2-step process. First process is first step is formation of alkyl halide, and second method is elimination of alkyl halide, which is called E2 elimination. Now moving some another examples. For examples, you say some aromatic compound, say toluene. This is called toluene. All of you know this compound. This is toluene. Toluene to say CH2 double one CH2. Sorry, this is not CH2. CH2 double one carbon CH double one CH2. This is called styrene. One of the most important compound. This is called styrene. This is not toluene. This will be ethyl benzene, CH2CH3, which is called ethyl benzene. So this is one type of hydrocarbon, which is aromatic hydrocarbon. We can say it is an alkane aromatic hydrocarbon or alkanes. Aromatic hydrocarbon, not alkanes. It is aromatic hydrocarbons, and this is due to the presence of this ring. So how can we convert this type of problems? Ethyl benzene to styrene. You see that what is the change? This is CH2 CH3 to CH11 CH2. Both this carbon was sp3. This is also sp3, and now it becomes sp2. It becomes sp2. So basically, the change of an alkane to a alkene. Am I clear? This is the actually the change of an alkane to alkene. You see, this part is same. This part is same. There is no change of benzene nucleus. So where change is happening? The change is happening here. CH3 CH2 to CH11 CH2. So this is alkane type and this is alkene. So actually this conversion is a types of conversion where we have to convert an alkane to alkene. So now we'll try to do that. So our initial compound was ethyl benzene, CH2 CH3. So what we have already done in previous examples, we have to convert first alkane into alkyl halide. So here there are so many reagents for this types of conversion. This position is very important position, which is called benzylic position. Benzylic position. We use so many reagents for the conversion of this benzyl, this ethyl benzene into ethyl bromobenzene. The reagents are, one of the most important reagents is NBS in CCl4. What is this NBS? This is called, this the full name is N-bromosuccinamide. N-bromosuccinamide, or you can use bromine in presence of HNu, or you can use chlorine in presence of HNu. Whatever you have used here, NBS, CCl4, bromine HNu, chlorine HNu, all are reagent, specific reagent for the halogenation of benzylic and allylic position. You must have to remember this. This is very much important. For the allylic and benzylic halogenation, what we have to use? We have to use NBS CCl4 or chlorine HNu or Br2HNu. So if you use NBS CCl4 or bromine HNu or Cl2HNu, what you will get? They say we have been used NBS CCl4. So we will get N-bromosuccinamide. If you used here, what we will get? We will get benzylic bromination. The bromine will attach here. This is benzylic position. What is this called? Benzylic bromide. Benzylic halogenation. Now it becomes CG. This is an alkyl halide. This is an alkyl halide type. If you see, this is alpha carbon, and this is beta carbon. So in beta carbon there is 3 hydrogen. So for elimination reaction, minimum 1 hydrogen is required. So there is 3 hydrogen. So just you have used E2 reaction, NaOH, ethanol. Will get the eliminated product, which is styrene. So only 2 steps. ethyl benzene used ethyl benzene to bromobenzene. How we have converted? We have converted by using NbHCl4 or N-bromosuccinamide or bromine HNu or Cl2HNu. We will get the brominated product in benzylic position and after that we used simple E2 reaction and we reached our final destination, which is a compound, which is alkene compound called styrene, one of the important compound, styrene. Let us take another examples. Propane to propene. Same types of example. Propane to propene. This is alkane and this is alkene. Now see structure. CH3, the structure of this compound is CH3, CH2, CH3, and this one is CH3, CH double bond, CH2. So what is the difference? This is alkane, this is alkenes. So difference is here. Both this carbon is sp3, this is also sp3, and but here this is sp2, this is sp2. So anyhow, we have to introduce a alkyl halide, a halogen in number 2, in carbon number 2 or 3. If you introduce halogen in carbon number 2 or 3, then the process become easy. Just we have to do elimination reaction after that. Now see what the problem is. So easy. You can clearly see that. Bromine HNu. If you use here, what will you get as a major product? Br CH3 and do sodium ethoxide, NaOH, ethanol, which is called E2 reaction. This is alpha carbon, this is beta carbon, so double bond is occur at alpha beta position. CH3, CH double bond, CH2. This is called propene. Okay. So whatever example we have done, here the number of carbon atom becomes same. CH3, CH2, here 3 carbon atom, here 3 carbon atom. Now the question is, if the number of carbon atom is increased, say for example, you have to convert ethane to propene. Ethane to propene. So what will you do? What will you do then if the number of carbon atom is increases? Say for example, ethane to propene. No problem. There is no problem about that. Just you write down the structure and problem will be solved. Ethane CH3, CH3 and propane CH3, CH2, CH3. Sorry, propene CH3, CH double bond, CH2. Now, first question. What is the first question? Whatever comes in your mind is that how we can increase the number 1 carbon atom. So to increase this number of carbon atom, we have to move ethane to propane. Okay, understand? If you convert this ethane to propane, then we move from propane to propene. Whatever we have already done, this is also done. This conversion is types of conversion from lower alkane to higher alkane. We have already done in previous examples on the conversion of ethane to propane. If you convert this, we can easily convert from propane to propene. Now I am showing you ethane CH3. Let's do halogenation, chlorine HNO, CH3 CH2 Cl. Okay, CH3 CH2 Cl. What we use here, we may use Corey-House reagent or Grignard reagent. You can use CH3 Mg Br or CH2 whole twice Cu Li. What will get? Propane. Okay. Now from propane to propene, you use Cl2HNO, CH3CH, Cl, CH3 will get this product as a major product, and then elimination reaction, NaOH, ethanol, will get CH3, CH1, CH2. So this is the this conversion is the addition of two conversion. One is lower alkane to higher alkane, this one, and then alkane to alkene. This is the addition of two types of conversion. One is conversion of lower alkane. This is lower alkane to higher alkane. Higher alkane means number of carbon atom here is 2. That's why we call it lower alkane, and then here is 3. That's why we call it higher alkane. And then from alkane to alkene. So conversion is a type of process you have to do anyway. Whatever reaction you can use, you may be used. There is no restriction that you have to use the particular that type of reaction. You have to use any type of reaction, but you have to convert the compound anyhow. So whatever we have done, I am going to conclude here. In next class, I'll do I'll do some examples. Whatever we have done, just summarize. 4 types of conversion we have learned in this class. First one is lower alkane to higher alkane. Number 2, higher alkane to lower alkane. Number 3, alkane to alkenes. Now the reaction used for this type of conversion, are, first one is halogenation. Number 2 is first reaction for the preparation of symmetrical alkane. Number 3, Corey-House reaction. Number 4 is Grignard reaction. Number 5 is ozonolysis. Number 6 is Clemenson reduction, and number 7 is E2 elimination reaction. Okay, so to know these three types of conversion, you must have to know these 7 type of reactions and the reagent used. So if it is clear for all of you, then you can do any type of conversion related to this type of examples or this type category, which is fall in this type of category. I am giving some examples for your homework. Number 3, propane. Number 1, propane to NHN, ethane to propane. Number 3, butane to butane to propane. Number 4, butane to butane. Number 5, cyclopentane to cyclopentane. Okay, now I'm going to erase this. Number 6, propyl benzene to number 7, toluene to ethyl benzene. Number 8, ethyl benzene to toluene. So you do this 8 conversions in home, and you can send me message or you can call me anytime. If you have any doubt, you can send me message, or you can mail me, or you can WhatsApp me. My WhatsApp number is given here. I am giving the WhatsApp number you today: 9153581662. This is my WhatsApp number. So if you have any query or any questions regarding this class, you can send me directly message to this number: 9153581662. Ali sir. You just save this number as Ali sir. Okay. So whatever we have learned today, I am going to summarize in 1 minute. We have already seen in before repeatedly. This class is conversion class. That is how we can convert an organic compound to another organic compound. I am basically divided into some portions. Some portions, that means some types of compounds, some types of functional group. I have divided on the basis of functional group, on the basis of compound types. I have divided in separate part. In first part, what I thought, I will teach you how we can convert from one hydrocarbon to another hydrocarbon. All of you know what is known as hydrocarbon. One is saturated hydrocarbon, another is unsaturated. Saturated is alkanes and unsaturated alkene and alkynes. So the conversion begins from alkane to alkane. That means lower alkane to higher alkanes, and higher alkanes to lower alkanes. And second one is alkane to alkenes. These three types of examples I have done today. The reaction, whatever you have to learn for this, I have already written, I have already given. If you don't know about the reaction, you just go through this. The reactions are: one is halogenation of alkane, second one is Barth reaction for the preparation of symmetrical alkane, third one is Corehouse reagent for the preparation of unsymmetrical alkane, fourth one is Gigner reagent for the preparation of both symmetrical and unsymmetrical alkane, fifth one is ozonolysis, sixth is elimination with mainly E2 elimination, seven is Clemenson reductions, and finally whatever we have learned, that is benzylic halogenation also we have learned, which is known as benzylic halogenation by using NBSCCl4 and also some other reactions. So I think this is enough for this for today's class. You have to just remember the reactions and the reagent, and you can do easily any types of conversion. This is the most important and interesting part of organic compound, which is the conversion. To know the conversion properly, you must be remember the reactions, basically the name reactions and the reagent. So I am going to end the today's class. If you like this class, you can't forget to share your comments or any types of comments. I'm always saying this may be positive or negative. You may share. That doesn't matter. I am also learning. You are also learning. Learning is a give and take policy. Give and take policy. If you give something, I am also giving something. This is one kind of give and take policy. So a teacher can also learn from a student, as well as a student can learn from teacher. So we are just a process of giving and taken policy process. So without any hesitation, you can also call me in this number, or you can message first. If I don't reply, then you call me. Will mention your name and your questions, whatever you have doubt, you may send this to number, and also you can request for the class जो शायद मुझे इस क्लास का कुछ टॉपिक्स और इस टॉपिक्स का कुछ क्लास में से अच्छा होता है. You can also say, or you can also message me. For West Bengal students, they are also in Bengali medium or also English medium. They can also do this, but this is only the simple conversion. There is no English or medium or Hindi medium or Bengali medium. Or I think all students can understand. There is no written. There is no essay written. This is just only the you have to remember some reason. So thank you very much for your kind patience and for your encouragement. Your encouragement is my energy. I'll upload some video. I will upload more video in futures for your purpose. So Goodbye, good night. And lastly, if you like this video, please share and make some comments and press the bell icon. Thank you very much.